Hey folks, we're just going to start in about 2 minutes. Sorry for the delay, but since I was saying that we're going to get started at 5 after the hour, I just want to make sure I give people a minute to get in. I just had some extra things that I needed to wrap up real quick before I started. And we'll get going soon here, so just hang tight. Cool. All right, let's get started here. So, welcome to Study Hall, everybody. I think we've kind of got a recurring cast of people who are kind of regulars at this point, but yeah, I'll just kind of go over what this is about and what we're going to do. So this is a venue for you all to bring in any questions if you have any topics you'd like me to explore relating to beginner, intermediate Python topics. I'm happy to cover those. If you have a question related to the Learn material, feel free to pop it in at any time, even if I'm in the middle of taking a question or going through a topic. Always feel free to just put it in, and I can get to them as they come in. So that's the primary purpose, is to give everybody a venue to kind of access us and kind of have a place to just chat about Python and talk about Python problems and explore and play around in sort of a more free-form way than going through the material in like Premium Prep or just going straight through the Learn material. So yeah, do feel free to bring in any questions you have because that's really the primary purpose. We do have a question. Somebody requested that I cover a topic, and apologies, I need to pull up Slack on my phone because as usual, I'm just now remembering that I need to do that. Okay. All right, there you are. Got a few people replying in here. A few hellos. Hello, everybody. Cool. So somebody asked me if I could cover error handling. If I could go over like basic error handling features. So, or they just said if I could cover error handling. And yes, I will cover error handling. I'm not going to go way in depth into it. And there's a reason we don't have error handling. There's a few things that, like, if you know another programming language, or if you have some Python or programming experience, there's a few things that we kind of intentionally omit from Learn, and it's not because we don't want you to ever know those, or it's not because they're not important. It's because they're hard to deliver without making the material sort of larger than we think it needs to be. Material in Learn is very oriented around, like, okay, so what's a kind of a straightforward minimum set of skills and tools that you need to kind of build to become proficient in Python to the point where you can start doing meaningful problem solving. And error handling is good. There's a lot of ways that it's a little bit redundant to just condition checking. You can kind of, a lot of the things you can do with error handling, you can do in sort of a different way with basic control flow stuff. So in the interest of teaching sort of fewer things and creating kind of less weight on new people coming in, less weight on their shoulders to less things to learn. And in the interest of giving people an excuse to practice more control flow, we choose to omit error handling. Another reason is I taught, so about a year ago, I started teaching premium prep. That became kind of a central part of what I do here. And I decided to include error handling because it's like, y'all are going to love this. I'm going to teach error handling. And I had a whole class full of people who were like, oh, great, I'll write my code using error handling and I'll never get an error again. And I spent the whole rest of the 3.5 weeks of that premium prep class helping like a couple dozen people realize that yes, error handling is useful, and if you use it too much, you're going to write code that cannot throw errors, and it's going to be extremely hard because now the burden is all on you to figure out what's going on. Python will not help you anymore, right? So that's why I want to give this little spiel before I get into talking about error handling, because I learned the hard way that it can look like, oh cool, so this is how I can not get errors. That statement is technically correct, but it's not good. You generally, if your code is going to throw an error, you want it to be able to throw that error because you want to get a signal on if you correctly implemented the logic or not, if you wrote valid code. If you didn't write valid code, you want to know about it, right? So we'll kind of give some examples of that. Now, I just want you to look at this. It's not that I think error handling is bad. It's not that I think it's unimportant. And we'll talk about being able, what I think is cooler than catching errors that exist is writing functions that throw your own custom errors. And we'll talk about that as part of this as well. So yeah, I just want to give that little disclaimer. As you look through this, this is something that you want to use carefully and with caution, because you can end up kind of digging yourself in a hole that you don't want to be in. It was a good time. It was a very interesting time. Cool. And we got a question on break pass and continue next, and I'll take that next. And somebody's saying, I prefer control flow coming from JavaScript, but I know that it isn't always enough in Python. Yeah. I guess that's a way to look at it. Yeah. My governing principle is to use just regular control flow wherever possible, unless error handling really saves me a lot of work. I don't think I've found a situation where, like, personally, and I'm not saying it doesn't exist, but where I couldn't like write my code in a way that it would just either avoid getting the error that I was worried about, just kind of naturally, that I kind of had the logic built in so that it was just naturally safe against that error, or to like do something different where I'm using control flow to kind of get around it in a different way. But there are times when it's like you could do that, but catching an error explicitly is like really quick and easy, and I think that's totally fine. Like if you're not making any sacrifices and it's quick and easy to catch an error, then I'll do it. So, okay, so let me stop talking about it. Let me demonstrate some stuff. So first of all, I need an error to catch. So now I have to think of code that gives me an error. Oh, here's a good one. Something divided by 0. Let's run this code. Oops, node mon, and we'll start that. Bam, 0 division error. So that I get this 0 division error. So let's say I have some code, and let's do something like for I in range 10. Let's have an n equals, I don't know, 20, and we'll just say print, or maybe it would be fun if we just made an accumulator. ACC equals 0, and let's print ACC, do it out here, and I'll say ACC plus equals n over I. Why not? So we got a little accumulator, and I'm just, the details of what's happening here aren't that important. I'm just writing code that I know is going to give me an error. It's going to give me this 0 division error. And the reason I know that is because I know that Python throws an error when you try to divide something by 0. It throws a 0 division error. And I've just written this code just to kind of a random for loop. We've got an accumulator, and I'm trying to do this thing where I accumulate the sum of n over I. So the first number in the range obviously is going to be 0. So to naturally handle this, I could say, oh, well, I don't want to divide by 0. So I'll just start at 1 because I can't start at 0. And I could do that, right? Evidently, the sum of that is 56. So this is kind of the way around it. Another way around this would be to just say if I equals 0, this is the condition that I know is going to throw an error. So continue. We could continue, and that's just going to skip that iteration. Maybe I wanted to do like, I had like maybe, let's say an upper and a lower bound, A and B equals, I'll do these on different lines. A equals, why don't I call it start equals -3, and stop equals 10. There we go. So I could do start and stop here. Start at start and stop at stop. So if I had this situation, right, the range encompasses 0. It's no longer just at the beginning, right? So I could avoid just that particular situation that whenever I is equal to 0, it's just automatically going to continue. So in this case, and I wanted to show this first, right? In this case, I have, if I'm not specifying a start and I know I always want to start at 1, I can just do 1, and I just omit 0 explicitly. That's the preferable case. But if I can't do that, and let's say this, this for loop is governed by a start and a stop where the start may be a negative number, so I might end up including 0 in some way, I have to find a different way because I can't just omit the 0 from the get-go. So I have to omit the 0 in the loop somehow. And this is preferable to me. Just say, this is what I mean about control flow. This is the example I was giving about control flow. If I equals 0, continue. So we'll do I equals -3, -2, -1. Then I is equal to 0, and we'll continue. Continue just means skip one iteration. Skip this iteration. That's all that means. And then we'll skip that iteration. That way we don't do the n over I where the error occurs, and we move forward. So this is nice because it handles, in either case, if I could start at 1, which I'm constraining this problem to say that I can't do that, or if I just avoid that particular situation, generally it makes sense to take this approach. You're writing your code in a way where you're aware of things that could go wrong, and you're sort of catching them as they come up. An alternative is to do error handling. So in order to catch errors that may occur, we're going to start with a try. And try is a block statement. So it takes a colon at the end, and like everything else that takes a colon at the end of the line, the next part of the code is indented underneath it. Now try also takes an except, and you got to put your except at the end here too, and we'll just put a pass. Okay, so you have to say try, and then the code in the try block is the code that might throw the error that you're interested in. So in this case, we know that this can throw a zero division error. So what you want to do is you want to say except, and then where is it? Zero division error. So you get the error in your terminal, you copy it, and then you paste it in. Okay, except zero division error. You have an opportunity to name the error text. You could say as E or something, or you could just do this if you don't want to capture that error text. So this will catch a zero division error. It won't catch other errors. It will only catch a zero division error like this. And why don't we let's just throw a print in here. Now the except code is what's run when when the code in the try throws the error you're accepting on. Except also takes a block of text. That's the code that you want to execute, right? So we can say print we'll just say error, right? So if I run this code, you can see we got that error, and then it still does the sum, still sums over everything. Any questions about this? I know there's some other questions that I promise we will get to soon here, but I wanted to give this a good go because it's a good topic. It's a fun topic. Thinking everybody's good. Okay, so this will handle one error, but let's say there's something, I don't know, I'm trying to think of a good example of something else that might give an error. I would just have to add something. I want to get like a type error. I find myself accepting on a lot of type errors, but I forget. It's like my brain isn't oriented around like, see, right now I have to write code that gives an error. And I'm like, well, I'm used to thinking about how to write code that doesn't give errors. So let's see here. Let's just play around. If I do len is a function that takes in a type that has a length and returns its length as an integer. Integers do not have a length. There we go. Okay, so len gives us a type error. So remember that I said this is accepting on a zero division error, right? So let's say I want to do something like len ACC. So this is going to give me the length of accumulator. Accumulator is a number. It doesn't have a length. It's just a number. You might think, well, a number is a length or something. Well, a number is an integer is what we use to represent a length, but it's not a length itself. It's just represents something that has a length, a number of elements. Okay, so we say ACC plus equals n over I, so that might do our zero division error. And this actually will do a type error every time because it's going to give us the same error. So if I run this code, we're going to get, okay, we're going to get that type error. So this says that len or object of type float has no len, right? So in our code here, we're only catching the zero division errors. So sometimes you're like, okay, so a zero division error might occur, but also a type error might occur. So I got type error, and I recommend, like, when you get that error, you can just go in and copy it and just catch it right there. Excuse me. Oops. So we'll say type error. Okay. So type error, zero division error, type error, right? Okay. So that's going to run every time because we got that error every time. So you can, in the code you're trying, there may be multiple errors that you want to catch. And you can do that by adding an except block for each individual error that you want to catch. Now, this is how I want you to think about it. There is an exception to the way I'm framing this, and I'll be honest about it, but this is the way that I want you to think about it. If you have some code and you're like, I'm getting this error, and it would be just really easy to just say, if I get this error, just do this other thing instead. That's a great case to use error handling. That's a really good case. So you could say, okay, if I get this error, I'll accept on that specific error, the error that you're worried about. And this helps train you about, like, okay, well, which error do I actually care about? And you might think, well, all of them. I don't want to get any errors. Sure, like, ultimately, you don't want to get any errors. But you don't want to write your code in such a way that, like, it's hard to produce, it's hard to write, it's hard to read, or it's hard to manage or maintain, right? Because if it is literally incapable of producing, if it's incapable of producing errors, that's different than you wrote it correctly and it just won't produce errors. That's a very different scenario, right? So you want it to be able to tell you if something's wrong, so that you can fix it so that that's not wrong anymore, right? So therefore, I want you to think about your code like, if I get that specific error, I just have something else that I want to do instead. I could handle it in this other way, but I could handle it with try except. So I'll accept on that specific error, and then I'll run my alternate code. Sometimes your alternate code is pass. It's just like, just don't, like, sometimes you say, try this out. If it doesn't work, don't worry about it. You can accept on that error and then throw a pass in there, and it's just like, don't do anything. If that didn't work, then it's fine. Sometimes that is totally fine. By the way, this is the only, like, sort of permanent use that I know for pass, where pass isn't just strictly a placeholder. It's actually kind of useful in this case to just say, like, don't do anything. It's the only place that I know where pass is actually useful, not just as a placeholder, right? So that's something that's fairly common. You try it out, you accept on the error that you care about, and then you just pass. Or maybe you have alternate code that you want to run specifically if that error does happen. Maybe you have some other way you want to calculate it, whatever. You can figure that out. Let's try this. We'll go back to that for now. Okay, so that's the way I want you to think about it. Pick one error at a time and accept on the errors that you are aware of. And that keeps you thinking about how your code works, and it keeps you thinking about specific ways in which it can fail, and keeps you thinking about how to handle those as individual cases. That's how I want you to think about it. So there is a different thing you can do here, which is you can put an except, just a bit, it's just a bare except like this. This is going to work. You see a lot of try except blocks like this in Code Wars, right? But let's say this is not valid Python, right? This would be either a name error or, let's say, right? So this would be a name error and a syntax error. This is a mess. This line of code sucks. It's not a good line of code. Invalid syntax. Oh, wow. I am actually getting an invalid syntax error. That's actually wonderful. I remember doing this before, and that bare accept would just catch syntax errors. Okay, evidently I can't accept on syntax errors. Huh. That's actually very useful. I don't think you want to accept on syntax errors anyways. So I don't know if that was, maybe I'm doing something differently. Maybe it needs to be in a function for that example to work, or something. Or if maybe they just said, hey, let's just not allow that anymore. So I tried to give an example, but I'm actually glad that that example didn't work. So let's say, I think it'll catch a name error though. Yes, okay. So that's kind of actually a pleasant surprise. I'm glad you can still get syntax errors even if you have a bare accept, because you really want syntax errors. Because if your code is like messed up, you kind of need to know about it. If it's not even valid syntax, you need to know about that. So this case, this says zero division error, right? But in this case, I changed n to m, and I'm using something called m, but m doesn't exist. Normally, this would give me a name error. So if I try to use m up here, I'll get a name error. It says name m is not defined. Let's just do that there. Name m is not defined. But in this case, it's just catching it. So you don't want to use a bare accept because it'll catch everything. So if I do over, well, let's say I do m over I. So I've got a name error and a zero division error potentially, and a type error. Well, it says it right there. I'm like, what was this one? It literally says it right there. A type error that's going to happen every time. So this is just going to catch all of them. Doesn't matter. So the reason this is bad is, I guess with the exception of a syntax error, this code is error proof, and it doesn't mean that it's going to be correct or it's going to work. It just means it's not going to give you any feedback about what's broken, which is not a good thing. You want that, so that's one reason it's bad. The other reason is it's not clear. Except on what? All errors, I guess. I can imagine that there would be a time or a place where maybe this is called for. You're just like, hey, if there's any error of any kind, it could be a bunch of different errors. Just try this other thing. Maybe this try block is 200 lines long or something, and you're just like, if this whole thing fails, I have an alternative. So I'm not sure which error might happen, but if at any point any error occurs, I'll figure it out in a different way, So I could see the reason that this is valid is that there are foreseeable circumstances where you kind of might want to accept on any error. Those circumstances, though foreseeable, are not common. I've never encountered a situation where I needed to do that. And I'd be inclined to say that if I found myself in that situation, I might do that. I might do a bare accept like this, sort of as a stopgap until I fixed all the rest of the code base that got me into that situation in the first place. Like if you find yourself in a situation where you're in earnest writing code like that, and it feels necessary to do that, you might argue that the code base needs deeper maintenance and like an overhaul or other changes to prevent that from happening in the first place. It might take a while to implement those changes, so this might be something that would get you by. But the assumption should never be to use a bare except like this, unless you have a really good, you better have a really good reason. And I can't, I could foresee one potentially rising up, but I've never encountered it or heard of a situation that I thought like it was the ultimately right thing to do. So, okay. So that's error handling with the caveats. So quick takeaways for this. The code that might throw the error that that you want to handle, you put that in a try block. The try block necessarily is followed by at least one except block. And the except block in all cases, I'll say, at least for now, should specify a specific error that they're gonna handle. So you should be specific. And then that also gives you the ability to run special code for each particular error. You might want to do something specific if you get a type error and something different if you get a name error, or well, you shouldn't get a name error really, but you might want to do something different if you get a value error versus a type error versus a zero division error. You might want to handle all those differently, and that gives you the ability to do that. It also makes it explicit when you don't want to do anything special, you can say pass. And, in addition to being clear about, or in addition to being precise in handling errors correctly, you're writing explicit code that sort of is self-documenting. So that's a big value of doing some things like that. Cool. And then, of course, don't use a bare except. Error handling is fun. It can be very useful, but it's not something, it's just something you ought to be a little careful with. Okay, and I did want to mention, so that's one aspect of error handling. And I guess this isn't technically error handling. It's yes, I want to talk about raising your own custom errors. So let's say I have a so let's say I have an add function and I only want it to work. I want to add two numbers, but I only want to add them together if they're integers, right? So, right, and maybe I want to do this because I want to be sure that like I'm going to use like whatever the result is as an indexing point in a list, and I don't want to. For whatever reason, I don't want to cast a float as an integer. So the way this code stands, if I try to print, add ints 3 and 5 versus 3 and 5.3, I can't write this like this in a way that it will reject floats. Not just like this, right? I could do some type checking and catch that float. So I could say if type A equals float, or type B equals float, or better yet, I could say not equals int, right? Because there's a lot of things that aren't ints that aren't floats either. right? So if either type is not an int, then I want to reject it, right? I could do this, and I could say return. You'll see some code like this sometimes in Learn, like return A or B is not an int or something like that. And then we get this. This is kind of like an error. This is in the spirit of an error, but it's not really a proper error. I'm just returning something that is sort of an exception to what I would normally return. It's the idea of an error, but it's not really a proper error. So this would be, if this was an error, it would be a type error. So I got that type error here. And if I want this to actually act like an error, I can say raise type error. So we'll raise a type error. And we'll just kind of treat this as a function. We say type error and then parentheses, and then this is just the error message that we want it to have. So type error A or B is not an integer. And let's say, like I want it to be like, but you're still cool. I could write my own custom errors to like make me feel good about getting an error, so that even if I get an error, I'm like, I'm still cool at least, so probably wouldn't do that in real life, but just to demonstrate, you can put whatever you want here, just like any string, and it's gonna display. It's pretty common to have an F string in here, and you'll format something in. Let me see if I can be a little more precise with this. Maybe we need to handle these separately, so I'll know which one was not. I think we do need to handle these separately. So we could say expected type 0, which is going to give me int, found, we'll say this, we'll expected A to be type 0, found type A. And we'll just raise down here. Whoops, dang it, sorry. We'll just change that to B, okay. Have that colon. Okay. So this says, I just wanted to do this just to get this copied. We don't need to do type 0 here. We can just bake that in like that. So this said expected B to be class int, found class float. You can do something like that. And this, of course, can be an elif. All right. So that's raising your own custom errors, and you can raise any type of error, syntax error. We can make that a syntax error like that. It's not really a syntax error because it doesn't have to do with improper syntax. It has to do with a one of the types in here not being what it should be according to the constraints I have on this problem. So it can be really useful to raise your own errors, and that can enforce limitations on what the function can and can't do, which can be really useful. There are certain times where you can anticipate something working that shouldn't work or that should do something else. So I think probably many of you are familiar with this kind of syntax, this type checking approach, where you say the type of something is equal to one type or another, and you can handle it from there. Cool. All right. I'm not seeing any follow-up, any questions for error handling here. Okay. Okay, cool. Yeah, feel free to get any in there if you have any follow-ups, but I want to get into answering some of the questions that other folks had as well. Somebody's asking for some clarification with break, pass, and continue as well. So here's one thing, and I know I gave examples using continue and pass in the previous one. Well, hopefully that'll help, but here's one silly thing, and I kind of mentioned this. Cool, glad that was helpful. I kind of mentioned this in premium prep regarding break, pass, and continue. I always find it funny, no matter what language I've ever learned that has sort of similar for loops or similar loops to Python, no matter what language I've worked in that has similar loops, they always have a break, pass, and a continue. And they're always called break, pass, and continue. And it's always presented in that order. It's like, it's always said break, pass, and continue. And what I find really funny is that break and continue share a similar job. Break and continue help us control loops. Pass has nothing really to do with either of them. So I always find it funny in our own material we even do it, which I think is kind of okay. I just find it peculiar. It might be worth me bringing this up and saying, like, maybe we should, reorganize some of that, take pass out and teach it in a different place. But I remember when I was learning my first language, which was JavaScript, and they taught us break, pass, and continue. I'm like, okay, well, I've got these 3 things to help me with loops. And what it is that you have 2 things to help you with loops, and one thing that kind of does something different that's not unrelated to loops, but it's not related to loops in the same way that break and continue are. So break and continue's only domain is inside of a loop. The only place that they are valid, the only context in which they mean anything is inside of a loop. And I think you'll get a, I think you'll get a syntax error if you try to use it out. Yep, it's a syntax error. Break outside of a loop. You can't even use it anywhere. You can't even use it outside of a loop. Continue not properly in loop. It's kind of worded strangely, but fair enough. I get it. And then let's see, pass. Doesn't matter. So that, I remember when I was learning this and I was like really trying to like, okay, so I get what break does and I get what continue does, but then what's pass do? And then why is it necessary? And then it would like, I think I had to understand it, but then I would think, oh, maybe I don't understand the other 2 then, because the context was so different. Like maybe if I misunderstood the context for pass. And then once it finally clicked, I was like, that's so weird. Like, why would you include pass with break and continue? But that is like canonically the way it is everywhere, apparently. So let's see. So let's sort of reorganize these. Let's talk about break and continue. Let's talk about pass first, actually. And then we'll talk about break and continue, and we'll come back. So pass is valid code that does nothing. It doesn't do anything. And you might think, well, why would you do that? Why would you have a built-in keyword in Python whose purpose is to not do anything? And the reason is it's common for various reasons to want to write some code that is partially complete that you intend to come back to. The Python interpreter, Python being a white space formatted language, white space formatting is like, it looks clean and it enforces some good practices, or it can, if you do it right. If you do it, I mean, I think the way Python does it, it enforces some good practices in terms of standardizing the way your code is laid out and everything. But it does come with some limitations, or it can come with some limitations. One of those limitations is that when you write something, you write a line that that expects a block of code indented underneath it, indented under it. There has to be something indented under it. Python will not accept that there's nothing indented under it, right? So if I say, and I see people do this all the time, where they're like, I wish I had a good example, but I don't want to like deviate too far to like drum up an example. Let's say you're in the middle of some function, and you've got, I don't know, I'll just say an accumulator, and you're doing for L and A, and you say if L is greater than 10, or just kind of making something up, and then you say, oh wait, I need to check this other condition too, and we'll say if L is less than 20, and I know I need to return ACC. You see how my syntax highlighting is kind of starting to get a little messed up? This if is not the same color as that if. This return is blue. Or you kind of I'm used to seeing it as red in my editor with my syntax highlighting. It's not the same color as the if or the for or the def, So it's kind of looking a little bit off. You pay attention to your syntax highlighting. You'll get used to it after a while, and if it looks off, it probably means something's messed up, right? So I have these conditions, and let's say this is kind of the start of some logic that I'm going to implement, and I maybe have 3 or 4 or 5 more lines that I'll ultimately need to add to this, whatever this function is supposed to do. This is kind of just an arbitrary function that whatever. But you've got a couple conditions or maybe loops or whatever, or maybe you're writing a couple functions and you're just stubbing them out like this. So let's say you want to just run it to test something. So I'm like, okay, well, let's make sure I've got, let me put my eyes on L and see what it's going to be here. And I run this code, and then I get a syntax error, and I think, oh, okay, so I haven't even really gotten into solving the problem, and it's already messed up. I can't even like run it just to like test something, right? And if we look at this, I'm not even calling the function, and that's giving me an error. The error it's giving me is an indentation error. And it says expected an indented block. So the way around this is not error handling. The way around this is Python says, hey, you made an if, and an if takes a body of code indented underneath it, and there's nothing indented underneath it. Python's just like, put something there. Something has to be put there. So we could do like a print or something, just like, okay, shut up, Python. Leave me alone. I'm trying to do something. and then that's fine. And like I said, I'm not even executing this code. I'm just playing around. So you could do that. And I did this for a long time just because I was like, oh, all right, you need something there. I'll just put an empty print. You don't want to do that because that might mess up like what you're printing. It's going to print new lines and it might be confusing. So instead of like running a print command, like why do that when I could just say, hey, Python, I know that's empty, but things are going to be okay. I promise. I got you. I know what's going on. I meant to leave those empty. Just don't even do anything. I'll get back to it. And Python's like, okay, I trust you. You said you're going to pass. You know what you're doing. Of course, it's not like that because I'm totally anthropomorphizing a Python interpreter. But if we were to give it a personality, that might be how that would go. But yeah, basically this just declares, yes, your intent was to not put anything there rather than having that just be empty, which it can't handle. So that's what pass does. It's valid code that does nothing. The reason that that's important is there are places where there needs to be something. And obviously it has to be valid in order for it to not throw an error like a syntax error or something. So it has to be valid syntax, code that the Python interpreter won't freak out about, right? And pass is the keyword for that. There's, yeah, you might be used to doing different things like, you know, you could put in an empty string or like I said, print or whatever, but pass is formally the correct way to do it. Okay, cool. So that's pass. Let's do something like this. Oh, shoot, we could even just use this example. I didn't intend for this to actually turn into an example, but it is turning into an example. So let's say if I have let's do this. Let's say less than 10 and greater than 20. Okay. So I'm just thinking of kind of just a random problem to play around with. We'll just save this as sort of stage one. So let's say this is our first pass. This is our first, you know, kind of setup to this problem. So let's say I want to do something where I go through a list and I want to sum up all the numbers that are between 10 and 20. If I encounter, let's do this. Let's say if I encounter a number that's less than 10, I don't want to do anything with it. But if I encounter a number that's greater than 20, I just want to stop accumulating. I don't want to add any more, right? So let's do that. We'll do an 11 there, right? So the way that this list should get processed is 14 plus 19 plus 12. So 14 plus 12 is 16, plus 19, excuse me, it's not 16. 14 plus 12 is 26, plus 19 is 36, 45. Okay, so that should be 45. We're not going to add the 7. We see the 43. We don't add the 11. We're not going to add anything after this. So the result of this, let's just do this. Exp equals 45. And right, so we're not going to add any of these. They would be valid numbers, but since we had this number that's greater than 20, we want to stop adding things. So let's do, I'll just do my regular tests, res equals some function. I'll just call this inp for input. So I have my input, which is the list. I have my res, which is the result of the function with that input, whatever it's actually producing. And then I have the expectation. So I'm going to say, does the result match my expectation? And then I'm going to print my result. That way, if it doesn't match my expectation, I can see, well, what did I actually get? So this is just a little test that I like to do, or a way that I like to organize my tests. Okay, cool. So we can use break and continue to achieve this, right? So I could say, in this case, I actually could use pass, but for now, let's just run it initially. We'll get this test. You can see I'm going to print out every element, right? I have these conditions kind of stubbed out for me to start plugging things in, right? So, okay, what did I want to do if the element is less than 10? I don't want to add it, right? Let's write some code to add it in. So I'll say ACC plus equals element. And let's call this num because I know these are going to be numbers. Okay, so let's pretend we don't have any of this code. I run it. Well, I'm going to get 156. I know I wanted 45, so that's not right. Yeah. Cool. So sorry about that. I'll do this. So if I get a number that's less than 10, I basically don't want to do anything. I want to make sure that I don't run this line of code. So if I put a pass in here, well, it's not going to do anything here, but it's still going to move past it and continue on to this. So if I can find a number that's less than 10, what I want to do is skip this iteration. I want to skip this iteration. I don't even want to do anything else in this iteration. I just want to move on to the next iteration. Okay. So I find a number that's less than 10, I want to just move on to the next iteration. So if you find yourself thinking, I found a condition that tells me I just want to skip this iteration, instead of skip, write continue. I don't think it's a particularly well-named word, but like I said, Python's not the only language that uses this keyword for this purpose. Every language that I'm aware of that has such keywords calls them break and continue. Break makes sense. We'll talk about that in a second, but continue, I think, would have been maybe better named as skip, because that's kind of what it does. It skips an iteration. But continue is the word. So if it helps, you can read continue as skip an iteration or skip. So if the element is less than 10, I want to skip, so I'll say continue. If the element is greater than 20, I don't want to do any more adding. I never want to add another element. I'm going to stop looping, so I'll say break. And break is very simple. Break just stops the loop, just dead in its tracks, no more looping. There's not a next iteration to this loop. There might be a loop after it, right? This might be inside of another loop. But in either case, if these were nested inside of another loop, if this loop was nested inside of another loop, this break and continue would apply only to the loop that it is most immediately inside of. So if you have, loop A outside of, or if you have loop B inside of loop A, and you have a break or a continue inside of loop B, it's only going to affect loop B, not loop A, not the one in the outer scope. So, and getting that behavior to work involves, I would use a Boolean flag and a little bit of control flow, and there's not like a keyword to just do it to break an outer loop. You kind of have to manage it, and it's a little funky, but also don't think you find yourself in that situation that often. And if you're good at control flow, it won't be that challenging if you needed that behavior. So it's important to know, though, break and continue bear on the loop that they are most immediately inside of. So this one's going to skip to the next iteration. This one's just going to stop all iterations. So let's actually run that and check it out. Name L is not defined. Of course, forgot to change these. These need to be num. Perfect. This says true, and that gives me 45. Nice. All right. Do we have any follow-ups for break and continue? I give people a minute here for this. We have another question in here. It's a bit longer, so I just want to give folks just a minute to, if you have any follow-ups to this or the error handling question, feel free to put them in now. And then we're going to move on to this next question that's posted. Cool. I'm getting the sense that everybody's good to go. So we've got another one, and it's a bit long. Let me read through it. Oops. Okay, so we've got a few bits of code here. I was told to go through this question in the chat. I've gone through it I've gotten through the intro Python, but I don't feel like I grasped the concepts as well as I should. So I'm going through the prep again. This is one I haven't been able to solve. Looks like I have another challenge one of skipping loops. Oh, okay. Well, this is right in line with what we just talked about. That's kind of nice. The question asks, okay, let's kind of look at this. We haven't used the browser at all today. It's kind of nice, actually. I like to just be working in my terminal or my editor or my terminal when I can. Cool, so challenge one of skipping loops. Oops, and this is sum only evens, and I had some code in there. I didn't want to give it away. So sum only evens. Complete the sum only evens function, which will take a list of numbers and only add those which are even. So there's a few ways we could do this. And I just just carry over my tests from this one. So let's just kind of look at this real quick. This should be called sum only evens. Did I get that right? I sure did. Okay, good. And it looks like we have some example code. I see the example code being given, I suspect is like what would be the body of a function, but since you don't have a function head, I don't actually know if you included the function head. in the code that you submitted. So yeah, def. Let's just go over this because it looks like what you've got might actually work at first glance, at least. So let's just check it out. So it looks like this is the code being submitted. Okay. And it is tabbed in. Okay. So then is this taking in, what's the name of the, okay, LST, it probably doesn't matter what the name of the parameter is. Presumably that's this though, so we'll call that numList. And then, yeah, so since you didn't send in a complete function, I don't know if your function has a return or not, or a print where it should have a return. I do see a print total at the bottom, so that could be your problem. But let's presume that that this code lived inside of a function that looked something like this and concludes with return total. Oops, that is on a 3 space. Dang it. It's on a 3 space indent. Let me try to fix this. Oh shoot. Okay. There we go. Good, that's working. Okay, so let's try that. 44. I meant to do this. We'll say 14 plus 12 plus 18. I think that's all the ones. We get this 14 and then the 12 and the 18. Okay, I guess the rest are odd numbers. So that's 44. So I expect this to be 44. Okay. So in this case, this code works. This part of the code is the part that was sent to me. I didn't make any alterations to it other than like the tabbing, which I'm assuming was at least relatively correct. I did notice this is on a 3 space indent here, which as long as everything is like on the same level, it should work. Like this will work. Oh, right, because this needs to be on the same level. 1, 2, 3. Yeah, but it's not convention or good practice to use a 3 space indent. It's convention and it's good practice to use a 4 space indent. Some people like prefer to use a 2 space indent. I think if you're working in a language that is not white space formatted, spacing is a stylistic choice. I think in Python, I don't really agree with it I don't like spacing as a stylistic choice. You can make a lot of stylistic choices that aren't spacing. I'm not saying that that's what you're doing, but just for the record, like you can be creative with a lot of things, make the code kind of your own, but it's useful to keep the spacing standardized and regular so that it's actually gonna be compatible with everything. It's just cleaner and easier that way. Okay, cool. So let's actually submit this. I'm just gonna, dang it. I'm going to comment that out. We'll submit that and make sure that it works. So that's correct. So it looks like you got your logic correct. And given that I didn't see the entire function, I don't actually know what's going on. So if you want to send in the whole function tip to tail, then you can pop that in there and maybe I'll be able to see something. But I do at that second code block you gave me, I see that you're printing total here, like this. Oops. That is going to fail because it's expecting this function to return a value. This function has no return. It's going to write the value of total onto a console, whatever console this is running on somewhere. So somewhere on a server that Galvanize owns, the number for total just got displayed onto a console that isn't even being outputted to a screen and nobody's ever probably going to see. But it was written there. I assure you, it definitely was written there. If it were connected to a screen, it would have been written and visible on the screen if anybody had been looking at the screen. So that's what print does. It just writes that information to the console. What we want is a value to come out of the function. We want this function to evaluate, return. We want it to evaluate to whatever the value of total is. Cool. Yeah, you're welcome. Were you just, was it the return that you were missing? I'm curious now, but that's also no worries. I mean, it's a really common mistake to make. It's a very easy mistake to make. This is kind of a funny one because in this case, we can write this function without the use of continue. You just say, if the number is even, accumulate it. And if it's not, then there's nothing that happens in this loop. So it's a de facto continue. There's a lot of things like that where you just kind of change something around and you don't need to use a continue. I think in times where it's sort of obvious what's happening, it's preferable to do this way, and then you don't have to have a continue. But sometimes it's really nice to lay out your conditions in a way that sort of models how you're thinking about something, and continue can be a good help with that. You were trying to append for some reason. Yeah, I saw that append in there. I should look into that. Num list. Ah, okay. Yeah, you were trying to append to the total. I see. Yeah, you don't want to mutate your input either, because that can lead to unforeseen consequences. Cool. It's a good question. The print and return thing is, yeah, that's something that, yeah, I remember taking, like when I was learning, I remember that like needing a while to sink in, like, oh, just because I can see it being displayed on the console doesn't mean that that's what this function is actually evaluating to. And there's a different, there's return for that, and then there's print for display on the console. So it's a good question. Cool. I'm not seeing any other questions at the moment. Seems like this is pretty good. Let's see. I'm wondering, we've got about 15 minutes left. I think this would be a natural stopping place. We have a bit of time left. I have some preparation that I need to do for today's premium prep, kind of working on the materials. I think we covered a lot today, so I think I feel good about wrapping it up here. So if anybody has any questions, feel free to DM me. But yeah, we covered a lot. We talked about a bit about error handling. Feel free to start playing around with that. If your code starts like working but not working, like you run it and it runs but it doesn't do what it's supposed to do, it's probably using a little too much, using a heavy hand with the error handling, so that's a good sign to be specific with what errors you're accepting. or try to find a way around not using error handling. But definitely encourage you to experiment around with it if you want. Error handling is cool, it's fun, it can save you. There's certain times where it can save you a lot of work, trying to get around something that's pretty easy to just handle directly. So it can be a really nice thing, but it's definitely not necessary for the TI. So just consider it a side topic. Raising errors, similar sort of thing. Like, it's not necessary for the TI. We don't bring it up anywhere in Learn. If I were going to add one topic into Learn, it might be raising your own custom errors, because so it is right now at least a side topic, but major cool points if you know when and how to raise your own errors, So, and then as for break, continue, and pass, I think the rule of thumb there is break and continue go together. They help us control loops. Pass isn't like, it's not like you can't put a pass in a loop. It just doesn't really have anything to do with loops specifically. You could put a pass anywhere that's expecting an indented block of code that you don't want to put in there right now. So it's a placeholder. It's just a placeholder that you're going to get back around to. The only exception to that is actually an error handling. Kind of the two covered topics we covered are, I think, pretty well related. In error handling, if you catch a specific error, a good amount of the time, the thing that you want to do in the accept block is nothing, right? So you'll do accept, and then the error you want to accept on, error you want to catch, and then a pass, which is just like, okay, if you get this error, just continue on. You don't need to do anything. Sometimes that works. There's times when that's totally fine. Obviously, there's times when, like if you get the error, you have to do something else instead, and you can put that in the accept block. But for the times when you don't want to do anything specifically, you can just put a pass. And that's the only time I know, that's the only situation where I've seen pass as used as like, yeah, this is a permanent part of the logic of this code. So, and then aside from that, I'm not exactly sure. Like I said, I didn't see the entirety of the original code for this last question that was asked. I suspect it was just like a lack of return in the function, which is a very common mistake. So no worries. And so just remember, everybody, reminder to everybody to use use returns when you want to return from a function, and use prints when we want to display to the console. But yeah, cool. I'll wrap it up there. It's been fun. It's been a good study hall, I think. Hoping everybody is having fun. Quick side note, I've been talking with Tovio. I think Tovio is going to start taking Friday study halls, which will be a nice bit of a nice break for me. And I think it'll be good to get a little more variety. Tovio is good at talking about a lot of other topics, and I know they make a really good stream, and I'm sure you will really enjoy their streams. So highly suggest that you show up for those. And yeah, I'll see you around for next study halls, or if you're in premium prep, I'll see you this evening. Cool. All right, bye-bye.